So I talked a little bit in class just briefly about how you get scatter plots. In some cases you have things that truly do have a linear relationship, like distance equals rate times time, or force equals mass times acceleration. But if you do experiments in science class where you're measuring time and measuring distance and you're doing all of these measurements, when you actually plot the points for those, even though it's a linear relationship, you have error in your data. You didn't quite hit the stopwatch quite right, or you didn't measure things quite correctly, or something hit a bump, or so the points wouldn't exactly line up. Now, not everything is linear, and not everything is closely related, but that would be an example of how you could actually get a scatter plot. So a scatter plot, think about measuring distance and rate, or time and rate to get distance. When you graphed that, your time would be on the horizontal axis, your distance would be on the vertical axis because you probably try to keep the rate the same. So you'd have these two different things, two different variables, one on the horizontal axis and one on the vertical axis. Probably what you would see in this case is if you did distance and time, it would be, again, not perfectly linear because you'd have some errors and some mistakes, but it would do this. As you go longer, you travel longer, you go further. This would be fairly linear data with a positive association. As the time increases, the distance also increases. Negatively associated would be, again, they're somewhat reasonably, sort of fairly linear-ish at least, but as this horizontal one increases, the vertical one decreases. So if I think about a line, which we'll do a line of fit in the next section, a line that I could draw through that's kind of an average line, this one would have a positive slope, this one would have a negative slope. Now, you can have varying levels of correlations. In this case, this is a positive relationship or a positive correlation. It's fairly linear. It's not perfectly linear. Again, there's a little bit of a scatter to those, but this is linear, and I would say it is positive. Now, these don't line up as perfectly with the ones. You're going to have to do a little bit of hunt and search on your paper to find the right one. And I am learning a lesson not to write in this area. Again, this next one, these are fairly linear, but it's decreasing as it goes from left to right, so it's a negative relationship. These aren't linear at all, so I would just say nonlinear, because this goes up and then it comes back down. And this one goes up and down and up again. So I'm not even going to try to talk about whether it has a positive or negative relationship because it depends on where you are on the graph. I would just classify each of these two as nonlinear. This one, even though the lines are somewhat grouped in a linear fashion, I mean, I could think about drawing a horizontal line that kind of goes through those. When it talks about correlation and a relationship between two variables and one impacting another one, there really isn't a relationship here, because if I think about drawing a line, an average line through here, it would go something like this, and it would go straight across. Well, that means that as the value on the horizontal axis increases, there's no change at all in the value on the y-axis. So there's really, for our purposes here, there's no relation, or no relationship if you wanted to write it that way. In this case, I can actually show you, if I can grab a line here in just a second, and let me do this. I could draw a line, and that line would go perfectly through all of those points. All of those points would lie directly on that line. So it has a positive relationship, or correlation as we call it, a perfectly positive one. This R is something called a correlation coefficient. If it is positive 1, it means that these points are perfectly linear and the slope is positive. It doesn't mean the slope of the line is positive 1. If my points did this, and they were perfectly linear, this is not a vertical line, but the slope is still positive, these would also have a correlation coefficient of positive 1. So correlation coefficient is not the slope of the line. It just says, in this case, with a correlation coefficient of 1, it has a positive correlation, and a coefficient of 1 means these are perfectly linear. So this is a positive, perfect positive linear correlation. Now here, if I think about drawing a line that's sort of an average line through this data, it might go something like this. There's some things above, some things below. This looks like about an average line. It has a positive slope, so it's a positive linear correlation, but these points aren't perfectly linear, so notice the correlation coefficient is no longer 1. It's decreased some. This one might be about 0.9, it says, could be 0.85. The smaller this number gets, the closer the correlation coefficient gets to 0, the more scattered my data is. So a strong, but not perfect, a strong positive linear correlation. Now, this one is still positive. If I think about drawing this line of fit through sort of an average line, yep, it's still positive correlation, but the points are even more scattered. You notice back here they were much closer to linear, and here they're more scattered, so it's a weak positive linear correlation. Notice my correlation coefficient is down to 0.4 because my data is even more scattered. Again, the closer this correlation coefficient gets to 0, the more scattered it is. This is another one that is a perfect relationship. However, it has a negative correlation. So if I drew my line, it would go perfectly through all of those points, totally linear, no scattering at all. Notice the correlation coefficient is -1. The 1 means that it's perfectly linear. The negative means that it's a negative relationship. Again, the slope of the line is not -1. The 1 just means that it's perfectly linear. The negative means it's a negative correlation. This is also a negative correlation, but there's some scattering in these points. So this is the strong negative correlation. Again, a negative correlation coefficient because the line would fall as it goes from left to right, but still fairly close to linear, so this number's fairly close to -1. Just like on the opposite side, the closer this correlation coefficient gets to 0, the more scattered the data is. I could sort of, again, picture a line. This looks not totally scattered all over the place. There's like a negative line there, a line with a negative slope there. But the data is much more scattered, so it's a very weak negative correlation. And notice that my correlation coefficient is negative because the relationship is negative, but it's getting closer to 0, which means my data is more scattered. I couldn't even imagine how to draw a line through this. I don't see a somewhat, even this, although it's weak, I can see this trend where these are decreasing as they go across the page. I can't tell what's going on here at all. The correlation coefficient here is going to be pretty close to 0. This looks almost like a, the shotgun shot, sort of the way that those pellets scatter out. So there's no linear correlation, and the correlation coefficient is going to be pretty close to 0. Now, as it says in your notes, before you come to class on Monday, or the next time we have class, look in a newspaper or a magazine or online and find an example of a scatter plot. Make sure that the axes are labeled, not like this. They're actually telling you the real world meaning of these points. So the axes are labeled with those meanings. And then bring that to class because we're going to do something with it. Thank you.